Alright, for this last section we need to talk about hydrates. And hydrates are compounds that have water molecules actually bound to the atoms. They're not dissolved, they're dry solids, but there are water molecules attached to them. And the number of water molecules associated with each formula unit is written following a dot. So for example, sodium carbonate, decahydrate, the prefix tells us how many waters, decahydrate, 10 waters. We put the 10 waters attached after the little dot to show that there are 10 water molecules attached to every one formula unit of sodium carbonate. And you can see over here, these are all the prefixes that we use, just like any of the other ones we've seen before, and how you would write them, how you would name them. Okay, so the first part, the ionic compound part, that's naming the same way we know how to. And then the second part, the prefix says how many waters are attached to that compound. Now, when we analyze a hydrate, basically what you would do is you would try to figure out how many water molecules are attached. Okay, so you're trying to figure out the formula. And to do that, we would need to know if we had a sample of a hydrate, when we heat it up and the water evaporates and it becomes, it becomes anhydrous. Here's our vocabulary word. Anhydrous means without water. When you heat it up and the water evaporates and it becomes anhydrous, that loss of mass tells us something about how much water was attached to it. So when you're analyzing a hydrate, you would weigh it and then heat it up and then weigh it again and figure out how many waters were attached. And to do that, we're going to find a ratio of moles of water to moles of anhydrous compound. And it's kind of like finding an empirical formula. You're finding that mole ratio, okay, just like when you find an empirical formula, although now it's from one compound to another rather than element to element. So let's look at an example. A mass of 2.50 grams of blue hydrated copper sulfate, and as you can see, our X is in the place of how many waters we're trying to find. It's placed in a crucible and heated. After heating, 1.59 grams of white anhydrous copper sulfate remains. What is the formula for the hydrate, and we want to name it? Okay, so the first thing we need to do is, based on the loss of mass, we need to figure out how many, or what mass of water was evaporated. So we're going to take our initial 2.50 grams minus the remaining 1.59 grams, and what we lost is the mass of water. So we lost 0.91 grams of H2O. So now what we want to do is we want to figure out what this ratio is. We're going to have 1 mole of copper sulfate for every X moles of water. So the first thing we're going to do is we're going to take our masses and convert them to moles. So 0.91 grams of water over 1. We use the molar mass of water, so 1 mole of water has a mass of 18.015 grams. So there our grams cancel. So that gives us 0.0505 moles of water. Alright, now we do the same thing with copper sulfate, and if you remember, this final mass is just the copper sulfate. Anhydrous means without water. So we can take that mass and convert it to moles. We're going to need the mass of copper, or the molar mass of copper sulfate. So we add up copper plus sulfur plus 4 oxygens, and that would give us 159.608 grams per mole. So our grams cancel. And that leaves us with 0.00996 moles of CuSO4. Alright, now if this was an empirical formula problem, the next step to get that whole number ratio of moles is to divide by the smallest. So we're going to divide them all by 0.00996. And that gives this number a 5, that one a 1. So for every 1 mole of copper sulfate, there are 5 moles of water. So we just determined that our X is 5. So the formula for the compound, CuSO4 dot 5H2O, and the name of the compound would be copper sulfate and the prefix for 5 is penta, so we would call it pentahydrate. There you go. Okay, we will be doing more practice with hydrates in class.